Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college live lesson. Today we're looking at trig addition formulas, and we're looking at another example a little bit harder than the one we did before, but it's still based on the same thing. Bismillah ar-Rahman ar-Rahim. Let's begin. So let's get the example on screen. If you're following through in the book, it's chapter 7, example 8. The UK Pearson Edexcel book. Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. In this example, we are asked, or we are told that 2 sine of x plus y is equal to 3 cos x minus y. And based on that, can we end up with tan x in terms of tan y? So that means, can we change this around and manipulate it and work on it so that we end up with a formula where we've got tan x on the left is equal to, and then some stuff on the right hand side, which would include tan y. So it might be something like tan x is equal to 2 times tan y or something like that. So this time we have to kind of manipulate both of them. So normally we take one side and try and make it equal to the other, but that's not what this question is asking. This is saying, can we, based on what we're given, change it around so that we end up with tan x on the left. So we're only going to get tan x if we can get sine over cos, because one of the things you've learned, should have learned by now, is that tan can be written as sine over cos, or tan x can be written as sine over cos x. So that's what we're aiming for, to try and get the sine over cos somewhere along in the formula, so we can then replace that with tan. Okay, let's begin. Let's start with a copy of the formula given in the question, and what we want to do now is use our addition formulas for sine and cos and try and just change this around a bit. So the first thing is that sine of 2 angles added together, we can replace that with the longer formula. So I'll have, the longer formula is sine x cos y plus, then the other way around, sine y cos x. So that's the left-hand side done. That 2 needs to be multiplying everything, so I can either put brackets around it like this, or I could multiply both things by 2, but I'll just leave the brackets around it for now. Okay, now let's work on the right-hand side. We've got the cos x minus y formula, so let's begin with the 3. And now, if you remember the cos formula, it's cos x cos y, and then we reverse the sign, it's plus sine x sine y. So here we would also have the 3 followed by brackets. Okay, now what we want to do is end up with tan, so that means I'm going to have a sine divided by a cos. So let's choose what looks like cos on this side is cos x cos y. So let's divide everything by cos x cos y. Looks like we're going to have to multiply out those brackets first, so let's take that 2 and multiply it by the sine x cos y and the sine y cos x. So let's squeeze it in there. So just the 2 gets multiplied by each thing, and then similarly with the 3, we can take that 3 and multiply it by everything in the brackets. So let's make a bit of room, and the 3 can come in front of both bits, and we can now drop the brackets. Okay, nothing done much really except just multiplying out the 2 and the 3. So now let's divide. We want to get sine over cos. So let's divide everything by cos x cos y and see what happens, because we've already got cos x cos y. So let's try and stay consistent with that. So if we're dividing by a cos, let's divide by that cos x cos y. And hopefully you'll start to see that lots of things will cancel out. So I'm dividing every single thing by the cos x cos y. The only reason I know that I need to do this is because the question said specifically get things in terms of tan. And the only way you can do that when you've got sines and coses is to try and get sine over cos. And because we've got different sines and different coses, we have to look at what's common. Common is cos x cos y. So let's divide by that. So let's see what cancels. Hopefully a lot cancels. We've got cos y can cancel here. We've got cos x can cancel here. We've got cos x can cancel here, and the cos y can cancel. And here doesn't look like anything can cancel. Okay, now let's turn the sine over cos into tan. So here I've got sine x over cos x. That will turn into tan, so I'll end up with 2 tan x. Then this just becomes 2 sine y. But the sine y over cos y can become tan y. And then if we keep going, I've got just the 3 because everything cancelled. And then I've got here the sine x over the cos x. So that bit will become tan x. And then sine y over cos y can become tan y. Okay, so looking pretty good. So let's try and get all the tan x's on one side. So let's take the 2 tan y can become a minus 2 tan y on this side. We want the tan x's to be on the same side, so I'm going to have to take all of this tan x tan y and put it onto the other side. That's going to become a minus. To get tan x on its own, I'll have to factorize it out. So I'll have tan x and then factorize that out. So I'll be left with 2 minus 3 tan y. And that will be equal to whatever's left, equals 3 minus 2 tan y. And then because the question said get tan x on its own, then all I need to do is divide by whatever is next to the tan x and get that onto the other side. So that will come down to here. And that's your final answer. Tan x is equal to 3 minus 2 tan y over 2 minus 3 tan y. Join me again for more on trig identities, trig addition formulas, and the rest of the chapter. Assalamu alaikum wa rahmatullahi wa barakatuh.